Okay, so this video is to cover about equation of a plane. Okay, so in order to create the equation of a plane, so we have to have two conditions where the plane must has a point A on its surface. So point A, so that means a plane must be crossing the point A, and then the plane has a vector n that is normal to the surface of the plane. Okay, so let's say here is our plane within the axis of z, y, and x. So this is the plane that is across the three axes. Okay, so on the plane we have a point A. So point A is on the plane, and then the plane also has a vector n. This is a comma, not an n1. Okay, that n that must be normal to the surface of the plane, or in another words, perpendicular to the surface of the plane. So this is vector n at 90 degree to the surface. Okay, so that is the condition of our plane. So that means everybody we have a uniform plane. Okay, then on a plane we also have the point R, which is the point where it could be anywhere on the surface of the plane. The same thing as the point of R that we use for straight line. Okay, so now we want to find the vector of AR. Okay, so in order to find the vector of AR, we need to have the point of A and the point of R. Okay, given that the point of A is actually x1, y1, and z1, and then the point of R is x, y, and z. Okay, R is any point on the surface of the plane, so that is why we are given only the x, y, and z, not x1, y1, and z1, because R will remain as an unknown. Okay, so then we can find the point of the vector of AR will be equal to, from the origin, AO plus OR. Okay, so but we didn't have the AO, we only have the OA that we can determine from the coordinate of A. So then we can say that AR is equal to negative OA plus OR. Okay, so we know since the vector of n is actually perpendicular to the surface of the plane, and 2 points of A and point R are on the surface of the plane, so that also means the vector of AR will also be on the surface of the plane. So by the side view of our diagram, so this is point A and this is point R that lies on the surface of the plane, and right here we will have the vector n that is 90 degree or perpendicular to the surface of the plane. So as we can see here, if we take vector AR cross vector n, then it will be equal to 0 because they are in perpendicular. And then we substitute AR with negative OA plus OR dot n equal to 0. So then we will have negative OA dot n OR also dot n equal to 0, and we can have okay, and now we can change the vector OR into the vector R, and then vector OA into vector A, and then now we have R dot n equal to A dot n. So this is the equation of a plane. Okay, now since we have the equation of the plane, and now in the equation we have the component of R, component of N, and also component of A. Okay, since R is unknown, so we keep it as R, and now we want to substitute the N, A, and N with the vector component of I, J, K. So then our equation will be R dot N is alpha I plus beta J plus gamma K. Okay, so the N is actually the same thing that we use as a vector M in straight line. Okay, so it appears as alpha, beta, and gamma. And then for vector A, it is x1I, y1j plus z1k dot. Okay, so that is for another vector of N. And then we can proceed with the dot product. So R dot alpha I. So now we have x1 alpha, y1 beta, and z1 gamma. Okay, so here is your first equation that is known as the vector equation of a plane. Okay, so that is the vector equation of a plane. Okay, so on the right side of the equation, actually when you do the dot product process, you will obtain an actual number on that side. So this equation can also be rewrite as R dot alpha I beta j plus gamma k equal to D. So this D represent the actual number that you obtain from the dot product on the right side of the equation. Okay. Next, we continue with this equation that we have, and now we substitute dr with its component of a vector, so it becomes xi yj plus zk. So this comes from the position of point R dot alpha I beta j plus gamma k equal to D. And we solve for the dot product, and we have alpha x beta y plus gamma z equal to D. So this is your second equation known as Cartesian equation for a plane. Okay, so now let's look at an example. So this question wants us to find A, the vector equation, then B, the Cartesian equation for the plane that passes through point A and also has a perpendicular vector N. So now let's first we draw the diagram of the plane. So let's say this is the plane, and the plane passes through point A. So here is the point A, and also has a vector that is perpendicular of vector N. So as mentioned before, there are only two things required for you to form an equation for a plane. First is the point A, and then second is the vector that is perpendicular to the surface of the plane. So these 2 points are already given by in the equation. So what we need to do is just substitute it into the equation. So where the R dot N equal to A dot N. So R dot, our N is 2I minus J plus 3K equal to A is the vector from origin to point A. So this is the point A. So I plus 7J dot with N 2I minus J plus 3. Okay, so now we solve for the dot product on the right side of the equation, and we will obtain 1, 2, 7, and negative 1. And we have it equal to negative 5. So this is our answer for question A, where the vector equation of the plane. Okay, so next to do for question B, which is the Cartesian equation. So what we need to do is to expand or substitute this vector R with its component of ijk. So that will be xi yj plus zk dot 2I minus j plus 3k equal to negative 5. And then we proceed with the dot product, and we have 2x minus y 3z equal to negative 5. So this is our answer for question B, which is the Cartesian equation of the plane. Okay, so now I have one example of question to find a vector of equation of the plane that passes through points A, B, and C. Okay, so let's first sketch the point of A. So here is point A, B, and here is point C. So these 3 points create a triangle. Okay, so this triangle we can assume that as the plane. And to find the vector equation, what we need is we need a point. So that is already given by the question. We are given with 3 points A, B, and point C. And what only we didn't have is the equation of vector that is perpendicular to the surface of our plane. Okay, so this vector can be calculated, can be found by taking the vector of AB cross the vector of AC. Okay, when we do a cross product between two vectors, it will create another vector that is perpendicular to both of the two vectors. Okay, so now from the point of A, B, and C given, we can determine the equation for vector AB. There is I plus J, and for vector AC is equal to 2I minus J plus K. Alright, so the vector of N is equal to AB cross AC, and that is equal to I, J, K, 1, 1, 0. Okay. So it will be equal to I negative 1, 1 plus 1, J negative 1, 1 plus 2, and then we have K Okay, so our answer will be 1 plus 0 I minus 1 plus 0 J plus negative 1 minus 2 K, and that is I minus J minus 3 K. So this is the equation for vector N that is perpendicular to our plane. Okay, so we just already have the vector of N and just substitute it into the equation of the plane. Rn equal to A dot N. So we substitute R dot N is I negative J minus 3K, and then A. So for A, you can choose either point A, point B, or point C that you want to use. All three will give you the same answer. So for this one, I choose point A. So that will be just J, I minus J minus 3K. And then you proceed with the dot product. And you will have equal to negative 1. So it doesn't matter which point that you use. All three will give you equal to negative 1. So that is the final answer. Okay, so we proceed with the next example of question. So if you want to try this question by yourself, so I recommend you to pause the video for a while. Okay, so for the first question, question A, we have a plane P that passes through point A and is parallel to another plane. So by the diagram, so this can be the plane P1 that we have to find its Cartesian equation, and this plane is also parallel to another plane. Might be down here or could be anywhere, doesn't matter, as long as it must be parallel. And that plane, the equation is 2x minus y plus z equal to 5. And given that plane P1 is passing through point A at 2, 1 and 0. So what does we need to have to form the Cartesian equation is the vector of n that is perpendicular. So this vector of n can be determined by another plane that we have down there, because the question mentioned that the plane is parallel to our plane P1. So that means this plane where its vector of n must also be parallel to our vector of n for P1. So we just need to extract the vector of n from the equation given. So since this is the equation, we know on the left side of the equation is r dot n equal to a dot n. So on the right side is already been calculated in equal to 5. So we just let it be equal to 5. So we just separate on the left side of the equation where the x, yj plus zk. So this is the equation of vector r. And then the vector n must be 2i minus j plus k equal to 5. So this is what we are looking for, the vector of n. Okay, then we have the point and we have the vector of n, and we want to form a Cartesian equation. So r dot n, so r is dot with vector n is 2i minus j plus k, and our a 2i plus j dot 2i minus j plus k. And now we have 2x minus y plus z, and that will be equal to 3. So that is the Cartesian equation for plane P1. Okay, so the next question is that we have plane P2 that passes through point B. So firstly, just sketch the plane to help us visualize the situation here. So this is point B at coordinate 1, 5, 0. Okay, and this plane P2 is perpendicular to both plane of x plus y minus z and 3x minus y plus 2z. So that plane that is perpendicular to our plane P2 could be in this position, and another one could be in this position, because mentioned in perpendicular. Okay, so in order to create the Cartesian equation for plane P2, what we need is actually the equation of a vector that is normal to plane P2. Okay, so let's say this is the equation for plane x plus y minus z equal to 1, and this one is 3x minus y plus 2z equal to 5. So since these two planes are perpendicular, so that means the vector of n that is coming out 90 degrees from the surface of the plane must be in this direction, and another one must be pointing in this direction. So now let's label this as plane P3 and this is as plane P4. Now we will have N3 and we have N4 right here. Okay, so from that diagram or from that direction of vector, so our vector of n for P2 that we have been looking for, n will be equal to n4 cross n3. Okay, then it will produce a vector of n perpendicular to plane P2. Okay, so we have to extract the vector of n4 and n3 from the given equation. So we have n4 is equal to, we extract the value of n from the equation, so that will be I plus j minus k, and then for n3 equal to 3i minus j plus 2k. Alright, and then we do n4 cross n3 is alright, and then we have right here is I and plus k okay, so the equation will be 2 minus 1i minus 2 plus 3j plus negative 1 minus 3k and equal to I minus 5j minus 4k. So this is the equation for vector n. Okay, so now we already have the point of B and we have the vector of n, and then we substitute that into the equation of a plane. So from r dot n equal to a dot n, so r we expand xi plus zk dot n is okay, so then it will be equal to point B turn into vector I plus 5j dot minus 4k, and now we have x minus 5y minus 4z equal to negative 24. So that is our equation for the plane of P2.